Welcome. Today we're diving into Redis and its critical role in modern system design. Redis is more than just a cache, it's an open source in-memory data structure store that powers databases, caching, and message brokering. If you've ever wondered why Redis is so popular in high-performance systems, you're in the right place. We'll explore its architecture, persistence models, clustering, and the trade-offs you need to consider. Let's start by understanding what Redis is and why it's a go-to choice for engineers tackling speed and scalability challenges. Redis stands for Remote Dictionary Server. It's an open-source in-memory data structure store that can be used as a database, cache, or message broker. Redis supports various data structures like strings, hashes, lists, sets, sorted sets, bitmaps, and more. Its versatility makes it suitable for a wide range of use cases, from session storage to real-time analytics. Redis is known for its blazing speed thanks to its in-memory design, and it offers features like replication, Lua scripting, and different persistence options. Let's see how Redis fits into both monolithic and distributed systems. Caching is like your system's short-term memory. It stores frequently accessed data in memory, making retrieval lightning fast compared to fetching from disk-based databases. Redis excels as a caching layer, reducing the load on primary databases and speeding up response times. By storing hot data in memory, Redis helps applications handle more users and requests without breaking a sweat. This is why caching is a fundamental performance optimization in system design, and Redis is often the tool of choice. Redis keeps all its data in the server's main memory, unlike traditional databases that rely on disk storage. This design choice means Redis can handle millions of operations per second, with average read and write times under a millisecond. The trade-off: if the server crashes, data in memory can be lost unless persistence is configured. Redis's in-memory approach is what gives it its legendary speed, making it ideal for use cases where performance is critical. Despite its speed, Redis should not be your primary source of truth. From a system design perspective, Redis is best used as a supporting layer to boost performance, not as the main database. This is because Redis by default doesn't guarantee strong consistency or high availability, especially in the face of crashes or network partitions. Understanding this limitation is crucial when deciding where Redis fits in your architecture. Redis offers several persistence options to balance speed and data durability. You can choose from RDB snapshots, AOF logs, both combined, or even disable persistence entirely. RDB creates point-in-time snapshots, while AOF logs every write operation. Each method has its pros and cons, and the right choice depends on your application's tolerance for data loss and recovery needs. Let's break down these options in detail. RDB, or Redis database snapshots, capture the entire dataset at specific intervals. These compact files are perfect for backups and disaster recovery. You can configure Redis to save snapshots every few minutes or after a certain number of changes. The main advantage is fast restarts and easy backups, but the downside is potential data loss between snapshots if a crash occurs. RDB is ideal when you can tolerate losing a few minutes of data. AOF, or append-only file, logs every write operation Redis receives. This method offers higher durability, as you can configure how often data is flushed to disk, every write, every second, or never. AOF files are larger and can be slower than RDB, but they minimize data loss to just a second or less. Redis can also rewrite AOF files in the background to keep them manageable. AOF is a solid choice when durability is a priority. Which persistence model should you use? It depends on your system's needs. For maximum safety, use both RDB and AOF together. If you can tolerate some data loss, RDB alone might suffice. If you need near-complete durability, AOF is better, but be aware of the performance trade-offs. The key is understanding your application's requirements and configuring Redis accordingly. Snapshotting is Redis's default persistence method. It saves the dataset to disk in a file called dump RDB. You can configure how often snapshots are taken based on time and the number of changes. For example, Redis might snapshot every minute if 1,000 keys change, or every 15 minutes if just one key changes. This approach balances performance and data safety, but remember, recent changes can be lost if a crash happens before the next snapshot. Append-only file, or AOF, provides a more durable alternative to snapshotting. You can set how often Redis syncs data to disk, always, every second, or never. Always syncing is safest but slowest, while syncing every second offers a good balance. If durability is critical, AOF is your friend, but keep in mind the performance impact and larger file sizes compared to RDB. Redis cannot guarantee strong consistency under any configuration. All disk writes are asynchronous, so there's always a risk of data loss if a crash occurs before data is persisted. Even with AOF, you might lose the last few operations. This is why Redis is not suitable as a primary database when transactional consistency is required. It's important to design your system with these limitations in mind. A monolithic setup, Redis is a single point of failure. If the server goes down, so does your cache or data store. To improve availability, Redis offers clustering and replication. Redis Cluster allows you to distribute data across multiple nodes, providing some resilience against node failures. However, large failures can still bring the cluster down, so availability is improved but not absolute. Redis Cluster enables automatic sharding, splitting your dataset across multiple nodes. Each node is responsible for a subset of hash slots, making it easy to scale horizontally. If a node fails, the cluster can continue operating as long as the majority of master nodes are available. This setup boosts both scalability and availability, but it's not immune to large-scale failures. Redis Cluster uses a unique sharding mechanism based on hash slots. There are 16,384 slots, and each node manages a range of these slots. When you add or remove nodes, slots are reassigned without downtime. This approach allows Redis to scale out easily and handle larger datasets than a single server's memory could support. To enhance availability, Redis cluster uses a master-slave model. Each hash slot has a master and one or more slave replicas. If a master node fails, a slave can be promoted to master, ensuring the cluster remains available. However, replication is asynchronous, so there's still a risk of data loss if the master fails before changes are replicated. Redis cluster does not guarantee strong consistency. Because replication is asynchronous, writes acknowledged by master may not reach slave before a failure. This means acknowledged writes can be lost if the master crashes. For applications needing strict consistency, Redis may not be the right fit. However, you can improve safety using the wait command, which waits for replication before acknowledging writes. Wait command in Redis lets you require acknowledgements from replicas before considering a write successful. This improves real-world data safety, especially during failovers. However, even with wait, Redis can't guarantee absolute consistency. There's always a small risk of data loss. Still, it's a valuable tool for applications that need better durability without sacrificing too much performance. Partitioning or sharding splits your data across multiple Redis instances. This allows you to scale beyond the memory and processing limits of a single server. Partitioning can be handled by the client, a proxy, or the cluster itself. Each approach has its own complexity and trade-offs, but all aim to make Redis more scalable and resilient. There are several ways to partition data in Redis. Client-side partitioning lets clients decide where to store data. Proxy-assisted partitioning uses a proxy to route requests to the correct node. Query routing used by Redis cluster redirects queries to the right node. Each method has pros and cons, especially regarding complexity and support for multi-key operations. Partitioning isn't a silver bullet. Operations involving multiple keys are often not supported, and managing backups becomes more complex. Adding or removing capacity can be tricky depending on your partitioning method. Redis cluster helps with rebalancing, but other methods require careful planning. Always weigh these disadvantages before choosing partitioning for your system. Redis cluster uses hash slots to manage data distribution. Commands like migrating, importing, stable, and node help manage slot ownership and migration. These commands ensure data is moved safely between nodes during scaling or failover events. Understanding slot management is key to maintaining a healthy Redis cluster. Fault tolerance is the ability of a system to keep running despite failures. In Redis, fault tolerance depends on your setup. A single instance isn't fault tolerant, but clusters with multiple masters and slaves can handle node or process failures. However, not all configurations guarantee full fault tolerance, especially if multiple nodes fail at once. Designing systems with Redis involves trade-offs. You must balance speed, consistency, availability, and complexity. Removing or misconfiguring components can have costly consequences. Always consider the disadvantages and limitations of Redis and its features before integrating it into your architecture. Thoughtful design leads to robust, scalable systems. Wrap up: Redis is a powerful tool for caching, fast data access, and scaling out systems. However, it's not a replacement for traditional databases when consistency is critical. Use Redis for what it does best: speed and scalability, while being mindful of its limitations. Always read the documentation, understand the trade-offs, and design your system with care. With the right setup, Redis can be a game changer for your application's performance.